In 1977, humanity launched 2 spacecraft toward the outer solar system with a mission that seemed ambitious but finite. Voyager 2 lifted off on August 20, followed by Voyager 1 on September 5. Their original objective was to study the giant planets, gather scientific data, and continue outward. No one could know that these spacecraft would eventually become humanity's first explorers of interstellar space. The timing of the mission was extraordinary. The outer planets were positioned in a rare configuration that allowed a spacecraft to use gravitational assists. Instead of carrying enough fuel to travel directly between planets, Voyager could approach a planet, use its gravity to alter its trajectory and speed, and then continue toward the next world. It was like using the planets as cosmic stepping stones. Voyager 1 quickly demonstrated that the mission could produce discoveries far beyond expectations. As it traveled toward Jupiter, scientists prepared to observe the largest planet in our solar system up close. When Voyager finally reached Jupiter in 1979, the distant striped sphere became a dynamic world. The spacecraft revealed enormous cloud systems, powerful storms, complex atmospheric bands, and a planetary environment dominated by violent motion. The Great Red Spot, already visible from Earth, became something entirely different when seen from close range, a gigantic atmospheric storm larger than our planet. But Jupiter's moons produced perhaps the biggest surprises. Io appeared to be one of the most volcanically active worlds ever observed. Voyager photographed enormous volcanic eruptions sending material hundreds of kilometers above the surface. Instead of being a frozen and inactive moon, Io was a world undergoing constant geological transformation. Then Voyager looked at Europa. Its surface was covered with long cracks and unusual patterns. The relatively smooth ice suggested that something beneath the surface could be moving. Scientists began considering the possibility that Europa contained a liquid ocean beneath its frozen exterior. One planetary system had already revealed 2 radically different worlds, one dominated by volcanic activity and another potentially hiding a vast ocean. Then came Saturn. From Earth, Saturn had always been famous for its beautiful rings. Voyager revealed that those rings were far more complicated than they appeared through telescopes. They contained countless narrow ringlets, gaps, waves, and intricate structures. Small moons interacted with the rings, shaping their appearance and creating features scientists had never observed before. Saturn's moons were equally fascinating. Titan possessed a thick atmosphere rich in nitrogen, making it one of the most intriguing bodies in the solar system. Other moons revealed signs of geological activity and complex histories. But the mission split at Saturn. Voyager 1 made a close encounter with Titan, which redirected its trajectory away from the outer planets and toward the edge of the solar system. Voyager 2 continued alone. Its next destination was Uranus. In 1986, Voyager 2 became the first spacecraft to visit the planet. Uranus looked quiet and almost featureless, but beneath that appearance was a bizarre world tilted dramatically on its side. The spacecraft discovered new moons, rings, and unusual geological features. One moon, Miranda, looked almost shattered, with enormous cliffs and strange terrain suggesting a complicated history. But Voyager 2 still had one final giant planet to visit. Neptune waited at the edge of the known planetary system. And when Voyager 2 finally arrived, it discovered that even this distant, freezing world was far more active than scientists expected. The journey through the planets was almost complete. But the most extraordinary chapter was still ahead. The Voyagers were about to leave the familiar planetary neighborhood behind and enter an environment humanity had never directly explored before. Interstellar space. When Voyager 2 reached Neptune in 1989, the spacecraft completed one of the greatest planetary tours in history. Neptune appeared as a deep blue world surrounded by powerful atmospheric activity. Voyager detected enormous storms and extremely fast winds, demonstrating that even a planet receiving only a tiny amount of sunlight could possess a remarkably energetic atmosphere. Then came Triton. The moon looked frozen, distant, and seemingly inactive. Instead, Voyager discovered a world with strange terrain and evidence of active processes. Nitrogen geysers appeared to erupt from its surface, sending material upward into the thin atmosphere. The message was becoming clear. The outer solar system was not a collection of dead rocks and frozen objects. It was filled with active worlds. After Neptune, Voyager 2 continued outward. Voyager 1 was already far beyond the planets, moving toward the outer boundary of the Sun's influence. That boundary is created by the heliosphere. The Sun constantly releases a stream of charged particles called the solar wind. These particles travel outward and form an enormous bubble around the solar system. But the bubble has an edge. Eventually, the solar wind encounters the material and magnetic environment of interstellar space. Voyager 1 crossed the heliopause in 2012. Voyager 2 followed in 2018. For the first time, human-made spacecraft were operating beyond the heliosphere. And the environment they encountered was anything but empty. Voyager detected changes in plasma density, particle populations, and magnetic conditions. It also recorded plasma waves traveling through the extremely thin material between stars. This revealed something fundamental. Interstellar space is not a perfect vacuum. It contains particles, magnetic fields, radiation, and waves. The region between stars is an environment of its own. Voyager therefore became more than a planetary spacecraft. It became an instrument for studying the space surrounding our solar system. Every measurement helped scientists understand how the Sun interacts with the galaxy around it. But Voyager's scientific legacy is only part of its story. In 1990, Voyager 1 turned its camera back toward Earth. From billions of kilometers away, our planet appeared as a tiny point of light. That photograph became known as the pale blue dot. The image changed the way millions of people thought about Earth. Everything humanity had ever experienced existed on that tiny world. And Voyager carried another reminder of our existence. Each spacecraft contains a golden record filled with sounds, images, music, and greetings from Earth. It was designed as a message in a bottle sent into the cosmic ocean. But the Voyagers themselves will eventually fall silent. Their radioisotope power systems slowly lose energy. Engineers have already switched off instruments and systems to conserve electricity. Eventually, the spacecraft will no longer have enough power to communicate. Yet they will continue traveling. They will drift through interstellar space long after their scientific instruments stop operating. Their mission began with a simple planetary tour. It became a journey beyond the heliosphere. And it transformed our understanding of the solar system. Voyager showed us that Jupiter is a storm-filled giant, that moons can contain oceans and volcanoes, that distant planets can remain surprisingly active, and that the space between stars is not truly empty. Most importantly, it showed us that exploration does not always end when a mission reaches its original destination. Sometimes, the greatest discoveries begin after the planned journey is already over. Voyager was launched in 1977. More than 4 decades later, it was still carrying humanity's curiosity into the darkness. And long after Earth stops hearing its signal, those two silent machines will continue their journey through the Milky Way.